So combining drones and AI, what are the mining use cases that are possible here? So what it enables is you have your data outputs, which is geotiff or point clouds or a DSM. But now the AI layer can inject and you can easily analyze automatically where the issues are. And similarly on the geotechnical side, which is automated rock mass characterization. And what that means is essentially identifying different joints, discontinuities, faults, cracks in the rock. The DJI has been producing tremendous cameras these days now, which are able to pick up all this information. And AI, if you apply its automated identification of these positions of bedding and faults and different seams, can lead to huge improvements of how we design our high walls, how we do a better wall control, and how to do a structure analysis on these high walls. One is the compliance and the safety side, and that has an operational correlation as well, how we can save the cost. So AI can auto detect the crest and toe, which is essentially a line that follows for each of the high wall, and the measurement of this high walls becomes equally important, not just to kind of understand geometrically, but also how to design a proper blast, or how do we maintain a proper wall control. So identification of this crest and toe is based on AI, and then it determines where the issues are in different areas of the high wall with angle, height, inter-ramp angle, which is the difference between the different walls, catch bench width, which is the safety distance. If there is a slow failure will occur, whether the rock will catch in different levels of the high wall or not. So all this is a very making the drones are making safer with this frequent analysis. The way I see the tools when combined together with drones and AI here. And the last one here is more on the drill and blast side, which is an activity that happens on a daily basis in most of the mines, sometimes 3 or 4 times in large mines here. One of the key metrics that occurs is the overbreak and underbreak, and these are really a relation of the blast-induced damages that occurs in the high wall. If you are able to monitor that on a regular basis, if you fly every time a blast is occurring and you measure the overbreak, underbreak, you can update your geotechnical model or structure models on a real-time basis. Usually this information gets updated once in a 6 month. By the time, a lot of the issues that continues to happen and cascades at a overall larger operational performance that mine should have seen doesn't get noticed then. So if we can do that, where the issues are in the high wall with overbreak, which is the red hotspot areas where overbreak is, which we can identify very easily on a real-time basis, we are seeing more and more cost improvements there. Then there are other use cases such as identification of floor hotspots, or where the different changes are on the elevations in the floor. So if I bring in the equipment to move that material, I know exactly where the issues are. Identification of the parent deviation, where my drill hole is supposed to be drilled, but it's not drilled. If I can identify very quickly with another drone flight and combining AI to auto detect holes, another use case there. After the blast, when the material is on the ground, if I can identify where the different rock particle sizes are, that helps my crusher improvement. And then finally, which is another level of improvement, if I can bring my drilling information to see with the drone data exact hole position, what's the hardness and softness of the rocks are. So I can know exactly how to model my blasting conditions. What are the benefits that can come in, which means site throughput can improve by 5 to 10%, 10% reduction in overall operational costs of drill and blast, and then the 30% reduction in deviation from overall mine planning to what you are supposed to be doing.